Back. So this is chapter 3, section 3.3. How derivatives affect shape of a graph. In other words, from f prime, what can you say about f? What does f prime say about f? All right, let's go back to the basics. What does f prime say about f? To see how the derivative of f can tell us where a function is increasing or decreasing, let's look at this figure. You see, my curve is increasing from A to B, point A to B, then decreasing from point B to C, and then increasing again from C to D, right? So what's happening? Between A and B and between C and D, the tangent lines have positive slope. That is, derivative is positive between A and B and between C and D. When it's increasing, derivative is positive. Okay. On the other hand, between B and C, you're decreasing, so the derivative has to be negative. All right. Between B and C, tangents have negative slope, so derivative is less than 0. Less than 0 means negative. Thus, it appears that f increases when f prime is positive and decreases when f prime is negative. Okay. To prove that this is always the case, we use the mean value theorem. All right. So, an important test, increasing, decreasing test. Increasing, decreasing test. If f prime x is greater than 0 on an interval, then f is increasing on that interval. If f prime x is less than 0 on an interval, then f is decreasing on that interval. Okay, very, very important. Increasing, decreasing test. F prime x greater than 0, f is increasing. F prime x less than 0, f is decreasing. All right. Here is an example. How is that increasing, decreasing to be used? Find where the function fx blah is increasing and where is it decreasing. To find out where fx is increasing or decreasing, we need to first find the derivative of f. So differentiate f. So this gave me 12x cubed. This gives me 12x squared. This gives me 24x. And this gives me 0. So nothing to add. Notice 12 is common, even x is common. So 12x is taken away. Whatever is left, they have factored. Okay. Now, to use the increasing, decreasing test, we have to know where f prime is greater than 0, where f prime is less than 0. Okay. So, now here are important steps. So, to figure out where greater than and less than 0 occurs, first find out where f prime is equal to 0. So, step 2. So, step 1 is to differentiate. Step 2 is to find where the derivative is equal to 0. Look at the derivatives. Where are they equal to 0? This factor gives me x equals 0. This factor gives me x equals 2. This factor gives me x equals negative 1. 0, 2, negative 1. Okay? 0, 2, negative 1. You make these marks on your number line. So these were the numbers, if you remember, where f prime is equal 0. All right? Equal 0 gave me some numbers. And these numbers are very important because these become your cut points. They cut your real number line into pieces. So the first cut is here. So this entire piece that entire interval is one piece. The second cut gives you the second piece. The third cut gives you the third piece and the fourth piece, right? So we have 1, 2, 3, 4 pieces of the number line because of 3 cuts, okay? Which within each piece, what I call piece is an interval. Within each interval, f prime is either always positive or always negative. That's the point of it. Cut points are where f prime is 0, and outside the cut points you get intervals where your f prime is always positive or always negative. Now, how do we know where it is positive, where it is negative? Well, you start with some test point. Okay, so let's see. What are the factors? So figure out the factors of f prime. So factors of f prime are 12x, x minus 2, and x plus 1. They come in handy. 12x, x minus 2, x plus 1. Look at the chart. Aha. So you have the first piece to the left of negative 1, second piece between negative 1 and 0, third piece from 0 to 2, fourth piece from 2 onwards. You remember? First piece to the left of negative 1, second piece between negative 1 and 0, third piece between 0 and 2, fourth piece 2 onwards. Okay, those are the intervals. Here are the factors of f prime: 12x, x minus 2, x plus 1. Remember that? 12x, x minus 2, x plus 1. They are factors of f prime. So intervals on one column, factors on the other column, and f prime x totally. So to the left of minus 1, choose a number. Which number do you like? I like number negative 2. I plug in negative 2 here. I get negative 24. So the value on that interval here is negative. I take that same test point negative 2, plug in here. Negative 2 minus 2, negative 4. That's a negative here. Take that negative 2, plug in here. Negative 2 plus 1 is a negative. Negative 1, that's negative. So what is f prime? F prime is product of these things. That is, I have to multiply these three. See, I don't care about numbers. I just care about sign. Negative times negative times negative. 3 negatives is a negative. So on. Between negative 1 and 0, choose a number. Say negative 0.5. Plug in here. Negative 0.5. 12 times negative is a negative. I don't care about the value, just the sign. Negative 0.5 minus 2, that will be even a bigger negative. Negative 0.5 plus 1, 1 is bigger. So I get a positive. Now multiply the signs. Negative, negative, positive is a positive. And so on. Between 0 and 2, take a number, say 1. That's a positive 1. So that gave me positive. 1 minus 2 is negative. That gave me a negative. 1 plus 1, that's a positive. Multiply, that's a negative. Greater than 2, say 3. Positive. 3 minus 2, positive. 3 plus 1, positive. Positive times positive times positive, positive. So this is how you determine the sign for f prime. Where f prime is negative, f is decreasing. Where f prime is positive, f is increasing. Decreasing, increasing. All right. So that's how you address this. Okay. So you can draw using, where am I? Where was the example? Yeah. Using any gadgets you like. Draw your example, and then you will notice decreasing, increasing, decreasing, increasing. All right. local extreme values. So this will be in our next video. Until then.